Hey, my name is Eden, and today I'll present you the paper Investigating the Value of Subtitles for Improved Movie Recommendations. This paper summarizes my master's degree in Software and Information Systems Engineering in Ben-Gurion University, and it's a joint research with Dr. Oren Sar-Shalom, Amit Livne, Professor Bacha Shapira, and Professor Dietmar Janach. So let's dive into the introduction. I'm going to briefly review a few concepts for a better understanding of the research. So recommendation systems are software tools and techniques with the goal of suggesting relevant items to users. It can either be to solve the rating prediction task or ranking tasks like top recommendations. Cold start is a phenomenon when the system does not have enough feedback from a user or on an item, or it can be both. Collaborative filtering is the main approach in recommendation systems. It relies on users, items, interactions, and it's highly effective to model user preferences, and it's very accurate compared to the alternatives. But it suffers from data sparsity and the cold start problem. For that reason, we have side information that can be integrated into the collaborative signals to tackle these challenges. One of the most popular domains which papers evaluate their algorithm on is the movies domain. But even though subtitles remained unused source for improving recommendation systems in this domain, background and related work. So the main three algorithms we relied on this paper are BPR, Bayesian personalized ranking, BERT, and LDA, which is latent directly allocation. BPR is an industry-trained method for item ranking, and the underlying ranking algorithm we tested on in this paper. BERT is an attention-based method which can be used for extracting representation from textual input using a pre-trained model. An LDA is a probabilistic topic model which we use for infer the latent topics and the distributions of the movies. BERT and LDA were the methods we used for visual extraction from the subtitles. Related work. This table summarizes the fact that we are the first to integrate subtitles for a hybrid recommendation system which solves the top recommendation task. Now let's discuss the methodology. So we propose in this paper a framework called SubtitleCF, which is a technical framework that combines user and item embeddings derived from interaction data and side information. The first component encodes the subtitles into an embedding vector which represents the movies, for example, by their topics. The second component integrates the subtitles-based representations into a collaborative filtering method. It can rely on any item ranking algorithm for learning the user item collaborative embeddings. In our case, we use a BPR as the underlying ranking algorithm, but other algorithms can be used as well. Component 1. We researched three different methods for extracting the subtitles representation, while the main ones were LDA and non-formal. In LDA, each movie encoded by its topics distribution which learned from the subtitles, and later on we used these intemperable factors to aid to the users with their decision-making process. In long-former, we utilize the pre-trained model to encode the subtitles, followed by PCA as a reduction technique to reduce the dimension. Component 2. The method we integrated the side information with the collaborative filtering and embeddings was in a pairwise summation, but other methods can be used as well as concatenation and using a fully connected layer. Now let's discuss the experiments we've done to test our framework. First of all, we created a new dataset named Sublens 20 million, which is based on the MovieLens 20 million dataset and contains its subtitles. Overall, we could match the subtitles of 71% of the movies, covering 98.3% of the interaction. This dataset is published in the paper for the community for further research. In the experiments, we divided each user's interaction to trend validation tests chronologically. We calculated accuracy metrics on the testset for each user independently and averaged it. We measured record precision and DCG for accuracy and catalog coverage, catalog hits for coverage. Catalog hits is a new metric we proposed to measure the coverage of the accurate recommendations. The motivation for that was that a popular biased recommendation system, which randomized one item, can achieve high accuracy with full coverage. But we wanted to test the coverage of the relevant items recommended to test how well the recommendation system recommend various set of items. So the metric calculates the proportion of the relevant items in the test set that was recommended for users divided by the total number of items in the test set. So, can subtitles help improve the performance of collaborative filtering? As can be seen in the table, the recommendation system which uses long-form of site information does not improve the general results. The reason for that relies on the fact that most of the test set consists of very popular items, the hottest ones, which means that a less popular biased recommendation system are prone to achieve lesser general accuracy results because of the risk it takes. But even though the recommendation system, which uses LDA site information, achieves the best result with small improvement in the accuracy metrics and the coverage one, around 3% improvement on the different accuracy metrics. We divided the items to 3 groups by their coldness level to test how well our framework handled the cold items. Each item belonged to a group called X if at most X users interacted with it in the train set. For example, an item will belong to the cold 10 group if at most 10 users interacted with the item in the train set. As can be seen, even though cold items is a small portion of the interactions, there are many of them. For example, in the cold 20 group, we can see that we have 33% of the items are cold 20, but they are responsible for less than 0.5% of the records. So when we expect how helpful is the use of subtitles in cold start situation, 2 phenomena can be seen. The first one is that both long-form and LDL-based algorithms achieve significantly higher improvement compared to BPR in dozens of percentage of improvement. The second phenomenon is the cooler the items get, the higher improvement. For example, in the cold 20 groups, the improvement are around 20%, but in the cold 5 groups are around 80%. Lastly, we wanted to test how helpful is the use of subtitles compared to another type of site information. So we compared our framework to the same one when we used synopsis site information instead of subtitles, and added an integrated version that integrates both site information and create one embedding vector to represent the movie. So generally, accuracy speaking, we can see that synopsis version beats the other algorithms. But when we look at cold accuracy metrics or the coverage one, we can see that the integrated version slightly win them all. We've done a user study to test another benefit can be achieved from the subtitles, which is how the subtitles can aid the user decision-making process. We've done a between subject study, which means that each participant belongs to one of 4 information groups. The minimal version, the first group, consists of the movie name, year, and poster. The topic version adds topics word cloud extracted using LDA site information vectors. The synopsis version adds the synopsis, and the whole group integrates all of the other 3 groups. We presented to the participants the corresponding information about the movie by the participant group and asked him to what extent he thinks he would like the movie, and followed with 3 questions regarding his difficulty answer, confidence in his answer, and the helpfulness of the information presented. So we have 2 tables which summarizes the results. The first table summarizes all of the results, while the second table filters only movies which the users indicated that they haven't seen before. So when we compare the results for the 2 groups between the minimal and the topics version, we can see that the difficulty, confidence, and helpfulness improved substantially in the favor of the topics version, and it was even more substantially when we look at the second table, the not seen movies. When we compare the synopsis version to the integrated version, which contains both synopsis and topics, we can see that the interest and difficulty improved to the favor of the integrated version, but the confidence and helpfulness slightly reduced and are better in the synopsis version. So for conclusion, the subtitles and site information has a high positive impact on the cold start situation. It increased the coverage of the recommendation system and can provide more explainable recommendations. Our contribution is the framework that we presented, SubtitleCF, NLP techniques for extracting information from the subtitles, a user study which researched the effect of subtitles on the decision-making process, and Sublens, the subtitled datasets, which is aligned with MovieLens 20 million. I invite you to read the paper for more details of our research. Thank you all for listening.